It's amazing, isn't it? I mean, this AI stuff, it just keeps accelerating. Feels like every week there's some new breakthrough, you know? Like, wow, how do we even keep up with it all?
Yeah, absolutely. It can definitely feel like a fire hose of information sometimes.
That's exactly why we wanted to take a deep dive into something pretty major that just dropped these Llama 4 models. You all asked us to really break it down.
And what we're looking at today is the actual, the official announcement, like straight from the source. We're going to try to cut through any hype or spin and just get to the core of what they're saying.
Exactly. We want to figure out, what is Llama 4? What makes it so different? And most importantly, why should you care about this next big step in AI?
Right. So we need to unpack this. They're calling it the Llama 4 herd, which sounds a bit intriguing. But it's not just one model, is it? It seems like it's a whole family of these things.
A whole lineup, yeah.
Yeah, so the initial Llama 4 release has 3 primary models, Llama 4 Scout, Llama 4 Maverick, and then they've given us a little preview of this beast they call Llama 4 Behemoth. So it's like a set of specialized tools, each one designed for a particular purpose.
Okay, so let's start with Llama 4 Scout. What's the big deal about this one? What's at the heart of it?
So Scout has 17 billion active parameters, and it's built using this architecture with 16 experts. And what they're highlighting is that for a model this size, it's the best in its class for handling both text and visual info, what we call multimodal model.
Right, multimodal.
They're saying it's way more capable than any previous Llama model, but can still run efficiently on just a single NVIDIA H100 GPU.
Wow, that's a lot of power packed into something that can fit on one card. They also made a big deal about its context window, right? Remind me, what exactly is that and why is Scout so special?
Right, so the context window is essentially how much information the model can take in and process all at once when it's generating a response.
Okay, so like it's short-term memory.
Kinda, but more like it's working memory. And Llama 4 Scout has a whopping 10 million token context window, which is huge. It's industry leading, actually.
Wow, 10 million. That's not just skimming the surface. That's like a super-powered memory.
It's like having an AI that can remember entire books, massive research papers, or tons of code all in one go. This really changes the game for handling complex tasks that involve huge chunks of information.
Okay, so huge memory, very capable. How does that translate into actual performance against the other big models out there?
Well, according to the announcement, Llama 4 Scout beats out some big names like Gemma 3, Gemini 2.0 Flashlight, and Mistral 3.1 on a whole bunch of those standard benchmarks. So it's not just about memory. It's actually really good at what it does.
So it's not all talk. It actually delivers.
Exactly. Imagine researchers feeding it all the research in their field, like everything, and then asking it to find connections no one's ever seen before. That's the kind of power we're talking about.
All right, so that's Scout. Huge memory, strong performance. Now on to Llama 4 Maverick. This one also has 17 billion active parameters, but they said it uses way more experts, like 128, right? What's the impact of that? Why so many experts?
128 experts for Maverick. So even though it has the same 17 billion active parameters as Scout, the experts make a big difference. And like Scout, Maverick is considered best in class for these multimodal models. But the focus here is really on pushing the limits of overall performance.
So it's like they took Scout and then cranked it up to 11.
Pretty much. The more experts you have, the more specialized each one can be, leading to this really fine-grained understanding and processing of information. And that directly translates into better performance.
Okay, I'm starting to get it. So how does this expert boost actually play out in real-world scenarios? Like, how does Maverick compare to other models in terms of what it can do?
Well, they claim that Llama 4 Maverick actually outperforms some of the current top dogs models like GPT-4o and Gemini 2.0 Flash on a wide range of tests. It even gets comparable results to DeepSeek V3 on reasoning and coding tasks, but using less than half the active parameters.
Wow, less than half. That's really impressive. They also talked about the cost-effectiveness of Maverick. Why is that so important?
It's huge, especially if you're thinking about actually using these models in the real world. Maverick has the best performance-to-cost ratio in its class, which is a big deal for developers and companies. They even shared an experimental chat version's ELO score on El Marina, and it hit 1417, which is very competitive.
Okay, so it's not just powerful, it's also efficient. So we have Scout, the marathon runner with incredible endurance, and Maverick, the agile sprinter with top speed. And then there's this Behemoth, right? The name itself sounds massive.
Yeah, Llama 4 Behemoth definitely lives up to its name. This one operates on a completely different scale. It's got a whopping 288 billion active parameters and utilizes 16 experts. They're saying this is their most powerful model yet, and it's definitely up there among the most powerful LLMs in the world.
So it's the heavyweight champion of the Llama family.
For sure.
What kind of performance are they seeing from this giant?
Keep in mind, it's still in training, but even so, the initial results are pretty amazing. They're saying it's already outperforming models like GPT 4.5, Claude Sonnet 3.7, and Gemini 2.0 Pro on a bunch of STEM benchmarks and, science, tech, engineering, math. So it seems to be really strong in areas like complex math and scientific understanding.
And it sounds like Behemoth isn't just about raw power. It also plays a role in developing those smaller models, Scout and Maverick, right? They call it a teacher model,
Yeah.
which is really interesting. How does that work exactly?
That's a key part of this whole herd concept. They use a process called distillation. Essentially, they take the knowledge and skills of a larger, more advanced model like Behemoth and transfer them to the smaller, more efficient models like Scout and Maverick. This helps the smaller models punch above their weight, so to speak.
Oh, I see. So it's like a master craftsman teaching their apprentices all the best techniques.
That's a great analogy. It's a really smart way to get the most out of Behemoth's immense scale and capabilities.
So for anyone listening who might be thinking, hey, I want to try this Llama 4 out, what's the availability like?
Well, the good news is that both Llama 4 Scout and Llama 4 Maverick are available right now for download on llama.com and Hugging Face. So if you're a developer or a researcher, you can jump right in and start experimenting.
That's awesome. They really seem to be pushing this open availability approach. Why is that such a big deal for them?
They're really emphasizing that this openness drives innovation. It benefits everyone involved, developers, Meta, the whole AI community. It's a core part of their philosophy and their strategy.
And it's not just about releasing the models, right? They're also incorporating Llama 4 into their own products, the stuff that people use every day.
Exactly. You can now experience Meta AI, which is powered by Llama 4, in things like WhatsApp, Messenger, Instagram Direct, and they even have a web interface. So you can actually see what these models can do firsthand in familiar apps.
So this isn't just some theoretical research project. They're putting it right into the hands of users.
Definitely. They're making it clear that this is a big step forward for the entire Llama ecosystem. More personalized, more intelligent interactions across a whole range of applications.
Okay, so let's dig a little deeper into the tech behind all this. They mentioned that Llama 4 is the first in the family to use this thing called a mixture of experts architecture, or MoE. What does it even mean? How does it actually work?
It's a really cool concept. In a traditional neural network, all the parameters, all the weights and connections are active all the time, processing every single input. But in MoE, only a specific subset of these parameters is activated for each input, and these subsets are like specialized groups of experts.
So it's like having a team of specialists, and depending on the task, you only call in the experts who are relevant to that particular job.
Exactly. And the selective activation makes MoE way more efficient, both during the training process and when the model is actually generating responses, which we call inference. So you get more bang for your buck in terms of computational power.
And this is a key part of Llama 4 Maverick, right? It has a massive number of total parameters, 400 billion, but only 17 billion are active at any given time. How do they manage that?
So they use these alternating layers of dense connections where every parameter is active, and then MoE layers. In Maverick's case, the MoE layers have 128 routed experts and a single shared expert. So when a piece of text or an image comes in, it's first processed by that shared expert and then intelligently routed to one or a few of those 128 routed experts that are best suited to handle that specific type of input.
Okay, so it's like a massive brain with all these specialized regions, but only the relevant parts light up for each task. That makes sense. They also talked about native multimodality and early fusion. What does that all mean for how Llama 4 understands the world?
This is a huge step forward. Traditionally, AI models would handle different types of data, like text and images, separately, and then try to combine them later. But native multimodality with early fusion means that Llama 4 models are built from the ground up to integrate text and visual information at the earliest stages.
So it's not just treating an image as one thing and a piece of text as another and then trying to make them talk. It's understanding them together from the very beginning.
Exactly. This early fusion allows them to do joint pre-training on tons of unlabeled data that includes text, images, and even video. And they've also made big improvements to their vision encoder based on their Metacolip model to make it work even more seamlessly with the language model. This tighter integration is key to creating AI that has a much richer understanding of the world around us.
Okay, so now let's shift to the pre-training phase. What were some of the key innovations or improvements they made there to give Llama 4 its amazing capabilities?
They highlighted a few things. One is called MetaP. It's a new way to set those critical training parameters, called hyperparameters, across different training setups. They found that these specific settings work really well no matter how much data you're using or how big the model is, which makes the whole process much smoother.
So they found a more reliable and efficient way to tune the training process.
Yeah, exactly. It's like finding a recipe that always works no matter how much you're cooking. It saves them tons of time and resources.
Awesome. What else did they do during pre-training?
Another big thing was their focus on multilingual capabilities. Llama 4 was pre-trained on a massive data set of 200 different languages, with over 100 of those languages having more than 1 billion tokens of text each. That's 10 times more multilingual data than they used for Llama 3.
Wow, 10 times. That's a huge jump.
It is. It means that fine-tuning these models for different languages, even less common ones, should be much more effective. They also focused on efficiency during training by using something called FP8 precision. It's a lower precision way of representing numbers, but they did it without sacrificing the quality of the models. And by using lower precision, they were able to achieve much higher computational throughput. They even hit 390 TFLOPs per GPU while training Behemoth.
So it's like finding a more efficient way to do really complex math, which is pretty amazing. And speaking of massive, the data set they use for pre-training is mind-boggling.
Right. Over 30 trillion tokens, more than double what they used for Llama 3. And it's not just text, it's a mix of text, images, and video. The sheer volume and variety of data is definitely a big reason why these models are so capable.
30 trillion. That's hard to even imagine. They also mentioned something called mid-training. What was the purpose of that?
So after the initial pre-training, they did this additional training phase called mid-training, using specific techniques to boost certain abilities, especially the model's ability to handle longer sequences of information. That context window we talked about. And that's how they were able to achieve that incredible 10 million token context length for Llama 4 Scout.
So it wasn't just one giant training run. They had specific stages and techniques to target specific improvements. Now, what about the post-training strategies? How do they fine-tune these huge models to actually perform well on all these different tasks?
That's where it gets really interesting. For Llama 4 Maverick, they focused on making sure it could handle different modalities well, like text and images, and they wanted it to be really good at reasoning and having natural conversations. They even developed a special curriculum for mixing different types of data during fine-tuning without messing up its performance on any one task.
So they're not just throwing data at it. They're being really strategic.
Absolutely. They also completely revamped their post-training pipeline. They went with a lightweight supervised fine-tuning phase, then online reinforcement learning, and then another lightweight direct preference optimization step.
Okay, a lot of jargon there. What does that all mean in practice?
They learned that doing too much of that fine-tuning stuff, the SFT and DPO early on, could actually limit the model's ability to learn during the reinforcement learning phase. And that's bad news if you want a model that can really reason and code well.
So they had to find a more balanced approach.
Exactly. They actually removed a bunch of their easier supervised fine-tuning data and focused on the harder stuff. And in the reinforcement learning phase, they also focused on giving the model harder prompts and developed a system where it could filter out the prompts it was already good at and keep the ones it was struggling with.
So they're constantly challenging it to learn and improve. That's pretty cool. And then the final DPO step just helps to make sure the responses are high quality and conversational.
Right. It's like the finishing touches. So this whole combination of a refined pipeline and continuous online reinforcement learning with adaptive data filtering that seems to be the secret sauce behind Maverick's success as a versatile chat model.
Okay, so let's zoom in on the individual models and what makes them special. Starting with Llama 4 Maverick as this general purpose LLM. We've talked about the architecture, but what are the key takeaways in terms of performance?
So again, Maverick has 17 billion active parameters, 128 experts, and 400 billion total parameters. The big news here is that it delivers really high quality, but at a lower cost than the much larger Llama 3 model, which had 70 billion parameters. And it's best in class for multimodal tasks, beating models like GPT-4o and Gemini 2.0 on a whole range of benchmarks: coding, reasoning, multilingual tasks, long sequences, image understanding, you name it. It even holds its own against DeepSeek v3.1, which is a much larger model, in those demanding areas like coding and reasoning.
So it's powerful, versatile, and efficient. Now back to Llama 4 Scout, the smaller model with that mind-blowing 10 million token context window. Besides just the length, what makes it stand out?
So Scout has 17 billion active parameters and 109 billion total, and it's already achieving state-of-the-art performance for models in its size class. But you're right, that expanded context window is really what makes it unique. Going from 128,000 tokens in Llama 3 to 10 million opens up a whole new world of possibilities.
Can you give us some concrete examples of what that actually means for someone who might use it? Like, what can you do with 10 million tokens that you couldn't do before?
Imagine being able to feed it an entire library of research papers and then ask it to find connections that no human researcher has ever spotted. Or picture a software developer analyzing a massive code base, maybe hundreds of thousands of lines of code all at once, to find bugs or security flaws. It could even process years of financial reports or customer interactions to identify those key trends and insights. It's really about being able to understand and reason across truly massive amounts of information.
So it's not just summarizing a long document. It's about a whole new level of understanding. And they mentioned some special techniques for handling this extended context, right?
Yeah, so during pre-training and post-training, they used a context length of 256,000 tokens, which really helps Scout learn to generalize to longer sequences. And they showed some impressive results in what they call retrieval needle in a haystack tasks, where the model has to find a specific piece of information buried within that huge 10 million token context. They also showed it performing really well on 10 million tokens of code.
And there's that IRO-PE architecture, which sounds pretty important.
Right. IRO-P stands for interleaved attention layers without positional embeddings. And they also use this thing called inference time temperature scaling to help it generalize to longer sequences. The I even hints at the idea that they might be aiming for infinite context length in the future. It's really a fundamental rethink of how the model pays attention to different parts of the input, especially over really long distances.
Fascinating. So it's not just about having a bigger memory. It's about how the model actually processes and understands that information. What about Scout's multimodal capabilities? Does that long context help with visual understanding as well?
It does. They train Scout on tons of images and video frames, so it has a really broad understanding of visual concepts. It can even understand actions happening over time in videos and the relationships between different images. This lets it interact with multiple images alongside text for complex reasoning tasks. They even tested it with up to 8 images at once.
Wow, so it can handle a lot of visual input along with all that text. And they also highlighted this image grounding ability, right? What does that mean?
Image grounding is really cool. It means that Scout can accurately link the words in your prompt to specific things you see in an image. So if you ask it a question about a picture, it knows exactly what you're referring to. This makes visual question answering much more precise. And overall, they're saying that Scout is just better than previous Llama models across the board: text, code, images, everything.
Okay, so Scout is the long context efficient multimodal explorer. Now finally, let's talk about Llama4 Behemoth, the big teacher model. We know it's massive and it does really well on certain benchmarks, but how does it actually teach the smaller models like Maverick?
The main method they use is called code distillation, and they do it specifically with Maverick. They came up with a new type of loss function that dynamically adjusts how much weight it gives to Behemoth's softer predictions versus the completely correct answers during Maverick's training. This helps Maverick learn more effectively from Behemoth's deeper knowledge.
So it's not just copying answers, it's learning how to think from the expert.
Exactly. And this code distillation also helps to spread out the computational cost. They basically pre-compute a lot of stuff using Behemoth so that Maverick doesn't have to do those calculations itself during training. And if they introduce new data specifically for Maverick, they'll run Behemoth on that data to generate the teaching targets.
That's really clever. So they're using Behemoth strategically to make the whole process more efficient. What about training Behemoth itself? It's so huge. That must have been a challenge.
Oh yeah, training a model that big required them to change a lot of their usual methods. They found out that they had to be incredibly picky with the data they used for supervised fine-tuning. They actually threw out a whopping 95% of it and only kept the absolute best quality examples. And then they did this large-scale reinforcement learning to boost its abilities in reasoning and code generation.
Wow, 95%. That's incredible. It really shows how important data quality is when you're dealing with models this massive. And the reinforcement learning for Behemoth also had some unique aspects, right?
Absolutely. They focused on giving Behemoth those hard prompts that it initially struggled with, and they created a system that would filter out prompts that weren't helping it improve. They also made sure that the training batches included a really diverse mix of prompts, testing its abilities across the board. And this very focused approach helped to significantly improve its performance in areas like math, logic, and coding.
So they were pushing Behemoth to excel in those specific areas. And they also had to make sure it could still follow instructions, right?
Yes, that was key. They emphasized how important it was to use a wide range of different instructions during reinforcement learning to make sure it didn't lose its ability to follow directions and do a variety of tasks.
And I can only imagine the sheer computing power needed to train a model with almost 2 trillion parameters.
Yeah, it was a massive undertaking. They basically had to completely redesign their whole reinforcement learning infrastructure. This involved optimizing their MOE parallelization techniques and developing a completely asynchronous online training framework. And this new system is about 10 times more efficient than their previous systems, which is crucial when you're dealing with models this big.
10 times more efficient. That's a huge leap forward.
Definitely. It shows how they're pushing the boundaries not just in AI modeling, but also in the underlying tech and infrastructure.
Well, this has been a truly fascinating deep dive into the Llama 4 announcement. We've covered so much from the capabilities and efficiency of Scout and Maverick to the sheer power and teacher role of Behemoth. And we even touched on all the technical innovations and the sophisticated training methods. It's been quite a journey.
It has. The advancements we're seeing with Llama 4 are really significant. The move to MOE architectures, that native multimodality with early fusion, and that unbelievable 10 million token context window in Scout, it's all really pushing the limits of what's possible with open-weight AI.
So as you're listening to all of this, I want you to think about this. With AI models becoming this powerful, this efficient, and this accessible, what new doors might open in your own field of work or your personal interests? How might a 10 million token context window change the way you approach information analysis and problem solving? What amazing applications could we see emerge from AI that can truly understand and reason across both text and visual information? These are the big questions that this leap forward in AI invites us all to consider. And if you're intrigued, we encourage you to explore the Llama 4 models further. You can find them on llama.com and Hugging Face. And you can even experience some of their capabilities yourself by trying out Meta AI in their various apps. It's a really exciting time to be following this field.